Okay, cool. Because the next three special quadrilaterals we're going to talk about are all parallelograms. So you have got to remember all those properties that we wrote down because we're going to be learning about a rectangle, rhombus, and square. And in the definitions of those, it starts off saying they are parallelograms. So that therefore they have all of those characteristics that we listed on the other day. So we're on page 216. It starts off by giving us a definition of rectangle. It says a rectangle is a parallelogram with four right angles. Another way we could word that is it's a parallelogram with four congruent angles. So we know that angle T is congruent to angle R, so on and so forth. But you have to use it through that process. T, R, B, so on and so forth. It says, given that this quadrilateral, RECT, is a rectangle, list all right triangles in the figure. So this is they tell us right out of the gate that this is a rectangle. They want us to identify the four right triangles. I'm going to try to list them off in the same fashion, but then underline it or highlight them in a different color. So the first one we got is triangle RET. Next one we have is going to be ERC, so that's this one. And then we got the two bottom, triangle TCR. And then the last one, triangle CT. Alright, so I've identified these four right triangles. I've put them in different colors, so it's much easier to see them this way. It says, explain how you know the triangles are congruent. How do we know that these are congruent? Well, we know that this is a rectangle. They told us that. Therefore, it is a parallelogram with four right angles. So I know that in a parallelogram, opposite sides are congruent. Not only are they congruent, they're parallel. So I can say that is congruent to that. And I can also say that this is congruent to that. So we have segment RT is congruent to segment EC. And how do we know that? That's because opposite sides of the parallelogram are congruent. So Kara had asked earlier, when are we allowed to use those? As long as you're not trying to prove that fact, then you can use it in a proof. So right now, if I were writing a two-column proof proving that these triangles are congruent, I would be able to state this because opposite sides of parallelograms are congruent. Opposite sides of parallelograms. Congruent. Then I know that this is a rectangle. So all of these, all four of the interior angles are right angles. So if this was a proof, I would have to list those out. And so by definition, all of those angles are right. So just an example, I'd say like TRE. So angle TRE, this is a right angle. And how do I know? What's the definition of a rectangle?
That's four triangles.
Correct. I mean, you would have to list them all out, but I'm not going to sit here and waste time to just list all the right angles out. It can be a later process. But I know that the right angles because of the definition. So I can prove that all these triangles are congruent with side angle side. So I know that all of these angles are congruent, so all of these triangles are congruent side angle side. So the reason I'm writing this is just in case you have a proof. And I give you a rectangle and I say, prove that triangle RET is congruent to triangle ERC. You would find the pairs of opposite sides that are congruent. That's because it is a parallelogram, so opposite sides of a parallelogram are congruent. And and you know that this is a rectangle, and all of the 4 interior angles are right. All right angles are congruent. So if I wanted to say that this angle is congruent to that angle, so on and so forth, I would first state that they're all right triangles, and then I would state that they're all congruent, and my justification would be all right angles are congruent. So first state that they're right angles, then say that all right angles are congruent. Okay, so it says complete the theorem. The diagonals of a rectangle are congruent. Okay, and then it says explain how you know the theorem in item 2. So how do you know that they are congruent? That's correct. If I told you to prove it, what would be your last statement? Your last, I'm sorry, not statement, your last reason, justification? It's okay? Corresponding parts, right. So this is CPCTC. And that's what a lot of this activity 15 is going to be. Find 2 triangles where those are corresponding parts, and then prove those triangles are congruent, and use CPCTC. So yes, explain how you know. It's just CPCTC. The fact that all of these triangles are congruent, and the diagonals are all the hypotenuses. So all those right triangles are congruent, and all those hypotenuses are congruent. Corresponding parts of congruent triangles are congruent. Moving on. Item 3. Nope, item 4. How about that? It says list all the properties of a rectangle. Begin with the properties of a parallelogram. Well, since we just got done writing or listing all the properties of a parallelogram the other day, it's on that easel over there. We're just going to go ahead and skip that. We're just going to list the new properties that we know. But you cannot forget that a rectangle has all of those parallelogram properties. So diagonals bisect each other, opposite sides congruent, angles congruent, consecutive angles are supplementary. List goes on and on. But the new ones with rectangle, we've got that the diagonals are congruent. So that's a new one. By definition, you got 4 right angles. So a third one would be consecutive. Consecutive sides are perpendicular. That's a third one. But these are the 3 new ones. So yes, it's parallelograms, so it has all those. These are 3 new ones. Item 5 says given quadrilateral PI&K, given that's a rectangle, with coordinates P, I, and N, find the coordinates of point K. So in the section to the left, that's my notes. Go ahead and graph these. You should have enough space. All of these points are in which quadrant? The first quadrant. So there's no need to draw an X and Y axis where you have all 4 of the quadrants. You only need the first quadrant. Okay, so hopefully you got those 3 points labeled and graphed. We need to find where this 4th vertex is. Just by looking at the shape, we know we can connect those and connect these. It's going to be somewhere around here. We have to determine where. We're going to use just the properties of parallelograms and rectangles to figure this out. Since this is a parallelogram, because it's a rectangle, we know the opposite sides are congruent. So this side is going to be congruent to this side. It's also going to be parallel as well. So what I would do personally is, whatever the slope and the distance of this segment, it's going to have to be exactly the same over here. So however much it rises up and then runs over, it's the same thing that's going to happen over here. So I would make a right triangle, with that being my hypotenuse, and from I to N, this rises up 4 units, and it runs over to the right 8. So I know that this segment has to do the same exact thing, so I'm just going to recreate that right triangle. up 4. So that would make my y value change from 0 and go up to 4. And then my x values, I'm going to the right 8 units. So from 3 plus 8 would get me to 11. K would be at 11. And you can always check your answer. Since you know this has to be a rectangle, take a look at the distances and the slopes. So the slope of this side goes up 4 and over 8, so that's a positive 1/2. Same thing here, it's a positive 1/2. These are the slopes. For here, the slope is going to be a negative. Well, it rises up 6 and then over 3, so it's a negative 2. This one here, same thing, negative 2. And so just as Grayson pointed out, the consecutive sides are perpendicular. So you should notice that with your slopes as well. Your slopes should always be opposite reciprocals. Opposite meaning different signs, and then reciprocals talk about the fractions. So if this is negative 2 and positive 1/2, that makes sense. That these consecutive sides are perpendicular. Old Bobby has been in here all day just chilling. His name's Petrie. It's cool. Trainer? I'm trainer. That's it, Nate. Teach that. He's going to his little cup. Not my Anyway, so you can always verify your answer by checking the distances as well, because this length has to be the same as that length, and so on and so forth. So let's move on to item 6. It says, given quadrilateral TGIF, it's ironic, it's Friday, is a rectangle. Use the properties of rectangle and the figure to the right to find the following. Now, just because of time's sake, I don't want to do these examples, but I do want to mark up this diagram and make sure that we understand and we see all of the properties of these rectangles. Okay, so first off, it is a parallelogram, so you know that opposite sides are parallel and congruent, obviously. So I'm going to say that. So parallelogram, opposite sides parallel, and congruent. I know that all of these are right angles. I know that the diagonals are congruent. That's difficult to convey when you've got the two diagonals intersecting, but what I can do is I know that they're congruent and they bisect each other. So if I put remarks congruency there, I can also put it on these. So that is showing that all the halves are. So if you look at the 4 triangles that are being created by your diagonals intersecting, all 4 of these are what kind of triangles? They're isosceles triangles, okay, so you can say that your base angles are congruent. Another reason why that makes sense, and because these here are vertical angles and vertical angles are always congruent, since these 2 isosceles triangles have congruent vertex angles, that also means that their base angles are going to be congruent as well. And also that makes sense because this is a parallelogram. So since this side is parallel with that side, and you consider this diagonal as the transversal, this is a set of alternate interior angles. And this too is a set of alternate interior angles. The same thing's going to happen with your angles over here, because those are 2 different isosceles triangles. But for the same reason, you know that those angles were congruent.